All right, let's continue. So we're going to do another problem. So the ones that we've done before already, you end up getting something that you should know how to integrate. There is one trick that you have to sort of realize, and that's like recognizing when you have a perfect square. So let's do a problem where that happens. Okay, so let's take y equals e to the x plus e to the negative x over 4. Okay, let's take x going, I don't really care what, 0 to 1. Okay, now if you really want to, you could do this with cosh, but let's not. Right, you could do this with hyperbolic cosine, but let's not. Let's actually do it straightforward. Okay, so y prime equals e to the x minus e to the negative x divided by 4. Actually, that should be a 2. Eh. Okay, all right, so now we're going to do 1 plus y prime squared. Well, let's do y prime squared. Y prime squared is e to the 2x minus 1, sorry, minus 2 plus e to the negative 2x, all divided by 4. Okay, I'm just checking because I built this problem. I just want to make sure that I did it right. Yes, it looks okay. Okay. So now, let's set up the integral we're going to do. It's the integral from 0 to 1, the square root of 1 plus y prime squared, e to the 2x minus 2 plus e to the negative 2x over 4 dx. But now, here you have 1, and here you have minus 1/2. And that's going to give you plus 1/2. Okay? So that's going to be now e to the 2x plus 2 plus e to the negative 2x over 4 dx, which equals, this is a perfect square here. Okay? And then that becomes something that's easy to integrate. Okay? Again, you could do this with the hyperbolic cosine sign. Maybe we'll think about that as like a challenge problem at some point. Let's do another one. Like, we're just setting these up. So let's take x equal 1/3 square root of y minus 3. Here we have limits on y. So there's not really much difference, okay? All we really have to do is we just have to set up the symmetric problem. So this is going to be, in this case, the integral in y, okay? 1 plus, now it's going to be dx dy squared with an integral in y, okay? So let's just set that up, make sure it's something reasonable. So x is 1/3. That's going to be y to the 3/2 minus 3y to the 1/2. I haven't taken the derivative yet. I'm about to do that now. Okay. dx dy is 1/3 3/2 y to the 1/2 minus 3/2 y to the negative 1/2. Okay, I was just laughing because I was thinking, what if this one doesn't work? Oh, that's going to be terrible, but it is going to work. The 3's cancel all over, so dx dy equals 1/2 y to the 1/2 minus y to the negative 1/2. Okay, again, just like I did here, when I squared it, I did this squared minus 2 times these two plus this squared, and the minus comes from here. Same thing here. So dx dy squared is going to be, there's a 1/4 there, y minus 2 plus 1 over y. Okay, I want you to make sure you understand how that came about. This y is this squared. The 1 over y is the y to the negative 1/2 squared. The negative comes from the negative in between, and 2 times the product of these two. But what's y to the 1/2 times y to the negative 1/2? If you said 1, you are correct. Okay? So this integral becomes from 1 to 9, the square root of 1 plus y minus 2 plus 1 over y over 4 dy. Again, 1 minus 1/2 equals plus 1/2. Okay, so that's going to equal, pull out the 1/2. Remember, square root of 4 is 2. Y to the 1/2 plus y to the negative 1/2 dy. Okay? All right, I'll leave it there. I'll do one more in the next video. All right?